In this video, I'm going to go over some things that I left out of the last video, and this is also going to lead you into the discussion on the Gatorade assignment. So if you remember last time, we talked about hydrogen bonds between water molecules. And in this image, which you've seen before, you see that these hydrogen bonds are constantly being broken and put back together. And then I showed you this, where you've got millions and billions of water molecules. You've got this interaction going on between them because of those hydrogen bonds. Now, what I ended up last time was I talked about the slide, but I didn't go through it in detail. So now I'm going to go through it in more detail, and that's going to lead you into being able to do the Gatorade assignment. Okay, so what happens when something dissolves? What does that mean, and why is that important? One thing I want to reiterate with ions, cations and anions, that ions are really important for your body. Positive and negatively charged atoms allow electricity to be conducted in your body. So every thought that you have involves these ions generating electricity in your brain. Every time your heart beats, there are ions that are moving that generate the electricity that allows your heart to beat. All your muscles, your other muscles, skeletal muscles, biceps, and so on, they need these ions in order to conduct electricity. And so ions are really important. Okay, so it is important that you have these ions in your diet, which we normally get as a salt. And then they dissolve. And then when they dissolve, they have these positive and negative charges that allow them to conduct electricity and allow physiology to occur throughout your body. Okay, so what's going to happen is we're going to use the examples of the bonds that we've talked about to talk about what happens when something dissolves. So imagine, or if you can get one if you want, get a thing of water, take some salt and put it in the water. And what you'll see is initially you'll see the salt, and then after a little while, especially if you squish it around, then it looks like the salt has disappeared. But it really hasn't. What it has done is it's dissolved. Now, if you taste that water, it will have a salty taste to it. So here's what's going to happen. Here's water molecules, and here are the hydrogen bonds that exist between the water molecules. And again, you go back to this image here. What's really happening is these water molecules are moving around. That's hard to represent on this, but that's what's happening. Okay, so you got the sodium chloride, a salt. What kind of bond exists between the sodium and chloride? By now, you should know the answer to that, and that's going to be an ionic bond. And then you've got this bond between the water molecules, which is hydrogen bonds. And you've got these water molecules moving all over the place. What's going to happen, if you remember, an ionic bond is not a very strong bond. So what's going to happen is when the salt goes in the water and these hydrogen or water molecules are bumping around, they're actually going to break the ionic bond. And so what you end up with in the water is you end up with sodium ions and chloride ions. So let's just show you a little bit. So this is representing the water molecules moving around, they bumping each other around, and then they bump into the salt, and then what's going to happen is the sodium is going to be a positive charge and the chloride is going to be negative, and that's not actually, it shouldn't be that close to it when I copied and pasted these. So now you've got a positive ion, okay, with sodium, which a positive ion, remember, is a cation, and then you've got the negative bond of the chloride, or not negative charge of the chloride, and that, remember, is an anion, and now you've got these ions. Now you've got these ions, and these ions can go on, and there's potassium ions and magnesium, bunch of ions. They can go on now and do the physiology that's needed to get your heart to beat, your brain to think, and your other muscles to contract. So that's the goal, and that's why water is so important, because it's going to allow these um, salts to dissolve in your body to produce these ions, which allows your physiology to occur. Okay, so again, you need to understand what kind of bond we started with. Okay, you need to know why the water molecules, the hydrogen bonds, how that's going to break up the salts to get into our, or end up with our ions. Okay, so like it says here, we now have ions. So that's one reason water is so important in our body. Okay, so let's apply this to something real life, and that is that's your concept map. Let me get out of this and get into the Gatorade assignment. Okay, so Gatorade, the use of Gatorade comes down to this physiology or this process that we just talked about. So Gatorade, out of all the sports drinks, and there's a lot of new ones that have come out that are like water that has stuff in them. But out of the sports drink, Gatorade is actually one of the best ones to use. It's been scientifically studied. One, it doesn't have a lot of fructose. You don't want a lot of fructose, and I think Powerade, last time I looked, has a lot of fructose, that will actually upset your stomach. So if you drink a bunch of it during a sporting event, the problem is when you go back in, you may end up throwing it all up. A good sports drink is not carbonated. There used to be a drink called All Sport. It may still be out there, but it was carbonated. That's just going to make you throw up too. So it has the right balance, Gatorade does, of it has sugars in it, which I'll talk about, and it also has these ions, and it also has water. So when you sweat, what do you lose? Okay, so that's going to be your first question here. And instead of having you look this up and come up with a lot of answers, we're going to focus on the two major ones. And the things you lose when you sweat is you lose primarily water, but you also lose ions. So that's why, when your sweat runs down and you taste it, it has a salty taste to it because you've lost those ions. Okay, the next question here is about what else is in Gatorade beside the ions in the water, and that is dextrose. That one you're going to look up. OSE, that should kind of ring a bell for you. If not, look it up. I will tell you that Gatorade used to have fructose, but now it does not. It's replaced it with this dextrose. So you want to look at what it is and what benefit it has. Question number 3 is sodium citrate. Sodium citrate is more complicated of a molecule than the sodium chloride we talked about, but I want you to think of it as an ionic bond between a sodium and a citrate. So the citrate and the sodium are together in an ionic bond. Okay? So what I just talked about in the slides on PowerPoint should help you with this. So why do you think sodium citrate is going to be beneficial? I've just answered the question when we talked about why it's important that you have salts and that they dissolve. So here it's going to have you explain an ionic bond, which you should already have an understanding of. It's going to have you explain a hydrogen bond, which you should already have some understanding of. And then I want you to go through for number 6. I want you to talk about, you're going to be reviewing this slide. Oops. This slide. So number 6 is explaining in words what happens in this slide. So when you drink the Gatorade and it's in your body, this process is going to occur. And so what you're going to do is explain that process. Okay, you're going to explain that process. It's going to show us that you understand what is going on. So after you do that, the next question is going to be, what are the benefits of drinking Gatorade over water when participating in an activity where it is hot and humid? So they have shown that if you're going to exercise for a short duration of time, that it's not really necessary to drink Gatorade. But if you're going to be participating, and I usually use football as an example because it's in the fall, at the end of summer really, where it's really hot and humid, you've got the uniform on, you're sweating a lot. Remember we talked about sweating, and can you sweat or can you evaporate as well when you've got a uniform on? So there's a loss of a lot of sweat, an attempt to cool off the body. So for short duration things in hot, humid weather, Gatorade's not needed. But when you start getting into these higher intensity, longer duration, very humid out, then yes, you're going to need to compensate by drinking more than just water. So it's going to ask you, what are the benefits of drinking Gatorade over water when participating in an activity where it is hot and humid? Okay. What you have to remember here is, remember, you are losing two things. You are losing both water and you are losing ions. So on your assignment is also this drawing. And so here's the balance, the homeostasis of the water ratio to the electrolytes. So there is a very set ratio between these two. Homeostasis. Compared to the amount of water, there's so many electrolytes. Remembering electrolytes are just ions. Okay? They're just ions. So what happens when you exercise, you lose both. If you just drink water, this is what's going to occur. If you drink Gatorade, then this is what's going to occur when you replenish. So what I want you to think about is, here is the ratio your body wants to be in, comparing the water amount to the electrolyte amount. Okay. You sweat, here's what happens. Then if you just drink water, here's what happens. So you should be comparing this one to this one. And then you should look at, okay, if you drink Gatorade, what happens? Look at this one and compare it to this one, and then explain why it is more beneficial to drink the Gatorade than it is to drink water in that situation. So that's an overview of this assignment. Okay, you'll be working in groups to do this and then submitting them, and then myself or whoever your instructor is when you're taking this will then grade it. All right, thank you.